In this video, we're going to do another example of solving a system of linear equations in 3 variables. So the first video did the first example, so this is the second example. Okay, so first thing we need to do is try to make this in upper triangular form. So we need to get the 2 off of this x because we just need the x by itself, and then the first equation can have x, y, and z. So to do that, just go ahead and multiply everything in the top by 1/2, and that should do it. So if I have x, then I'll have x plus 2 times 1/2 is also, so that would just be y plus z equals 6. Okay, so that's my new equation 1. So now for equation 2, I need to get rid of the x. Okay, so this x that's here cannot have it there. So to do that, I'm going to take this equation 1. So this is equation 2. Okay, so I'm going to take equation 2, and then I'm going to subtract, or I'm going to add on 3 times the equation 1, right? Because this is -3 here. If I do 3 times this, I'll have a positive 3 here, and then the x's will cancel. So let's do that. Okay, so I'll have 3x plus y minus 11z equals -6. And then I'll have 3x, so now I'm multiplying 3 by every term here. So 3x plus 3y plus 3z equals 18. Okay, now let's add them. Those two cancel, and that's what we wanted. We wanted to eliminate the x, and then we'll end up with having 4y here, and then we'll have minus 8z, and then this will be 12. Okay, so now this is my equation 2, but I need to get the y by itself, right? So I'm going to divide everything by 4. And I'll have 3, right? So if I divide all the terms by 4, then I get what I have here. Okay, so now this is my new equation 2. Okay, so this is the new equation 2. So let me go ahead and write that up here, up top. So I'll have y minus 2z equals 3, right? This is my new equation 2. Alright, so now for equation 3, I need to eliminate x and y. Okay, so to do that, first thing I'm going to do is I'm going to look here at equation 1. Alright, and if I multiply equation 1 by -2, then I'll cancel off this 2 I have here, this 2x. So let's go ahead and eliminate x first. So to do that, I'm going to have, this is equation 3, let me write that, E3. So I'm going to take E3, and then I'm going to subtract 2E1. Okay, so here's E3, 2x plus y plus 4z equals -8. Okay, now I need to do -2 times each of these terms. So -2x, -2y, -2z, -12. -2x, -2y, -2z, -12. Okay, these cancel, and that's what we wanted to see happen. For y, we'll have -y, and plus 4 minus 2 is plus 2z, and minus 20. Okay, now I need to eliminate y from this. Okay, so this is my new equation 3, but I still need to eliminate y, so I'm not quite done, right? Because equation 3 needs to have only z. So I'm going to look at my equation 2, and if I add those two together, then I should eliminate y. So equation 3 minus equation, or not minus, but plus equation 2 should do the trick. So let's go ahead and do that. So we'll have -y plus 2z equals -20, and then y plus or minus, so I'm looking here at this equation 2, or this one, our current equation 2. Alright, so minus 2z equals 3. Alright, these cancel. So do these. Okay, so then what do we end up having? We have 0 equals negative 17, which is not a true statement. Okay, false. 0 does not equal negative 17. This is an inconsistent equation, or inconsistent system of equations, right? Inconsistent system. And so, there's no solution. No solution, or you could write, so no solution, or you could write your solution set is the null set. Okay, there's no solution to this one. Okay, let's go ahead and do one last example. So again, we're going to start off by trying to get this into triangular form, and we see the top equation for equation 1, that's good to go because we have a leading 1 in front of the x, involves x, y, z, so it's fine. Alright, so the second equation, I need to eliminate x. Okay, so let's go ahead and label this. So this is equation 1, and this is equation 2. Sure, why not? This is equation 3. Okay, so if I need to eliminate x, if I take the equation 2, and then I add on 4 times equation 1, that should do the trick. Okay, because then I'll have 4x here, and then these will cancel. So let's go ahead and do that. We'll have negative 4x minus y minus 8z equals negative 29. Okay, and we're going to multiply 4 by everything in the first equation. So that would be 4x plus 4y plus 4z equals 5 times 4 is 20. Okay, these cancel. Then you're left with 3y and, let's see, minus 4z. And that equals negative 9. Okay, now we need to get y by itself. Remember, in triangular form, you have leading coefficient of 1 for whatever the leading term is. So let's go and divide every term by 3. Okay, to get y by itself. So we'll have y minus 4z over 3 equals negative 3. Okay, so let's go ahead and start writing our updated system. So the first one, we didn't change, x plus y plus z equals 5. Okay, now the new one, new equation 2, is y minus 4/3 z equals negative 3. Okay, so we still need to update the last equation, equation 3. And so first thing we need to do is get rid of the x, and then we'll get rid of the y. So to get rid of the x, let's see, I have 2x there, so 2x there. So if I do minus 2 times equation 1, that should do the trick. So let's go ahead and do that. So we'll have equation 3 minus 2 times equation 1. Okay, that should do the trick. Okay, so let's go ahead and write this out. So we'll have 2x plus 5y minus 2z equals 1. Okay, and then 2 times all the elements, or all the terms in equation 1. So that'll be 2x plus 2y plus 2z. 5 times 2 is 10. Oh, I made a mistake. I should have been multiplying it by negative 2, right? So negative 2x minus 2y minus 2z and minus 10. Okay, now these cancel, and I have 5 minus 2y, which is 3y, and minus 2z is minus 4z, and negative 9. Okay, so now I need to get rid of the y here. So this is my updated equation 3 as of right now, but I need to get rid of the y. So I'm going to use the updated equation 2 to do that. So I'm going to have equation 3, and then if I were to subtract off 3 times equation 2. That should do the trick. Let's go ahead and do it. So 3y minus 4z equals negative 9. Got that from down here. And I'm going to multiply every term by negative 3. So I'll have negative 3y. Okay, I'm looking right here. I'm multiplying every term by negative 3. So negative 3y. If I multiply this by negative 3, I'm going to get, so change sign, so it'll be positive, and then the 3 will cancel. So that'll be plus 4, plus 4z, and then the last, if I have negative 3 times negative 3, that's going to be positive 9. These cancel. That was the goal, but it just so happens these also cancel, and actually so do these. So we end up getting 0 equals 0. Okay? And so that's our updated third equation. But 0 always equals 0, right? So that's true for all z, right? So now we know we have a dependent system where there's infinitely many solutions. And then when we're writing our answer, we're going to write our answer with regards to z. So z equals z. And so let's go ahead and solve for y in terms of z. So looking at equation 2 up here, okay, I'm going to solve for y by subtracting this from both sides. So y equals negative 3 plus 4/3 z. Okay? All right, now let's solve for x using the first equation. So x equals 5 minus z minus y. Okay, we just solved for y, so that's z minus 3, or plus 3, because the minus and minus cancel, and then minus 4/3 z. Alright, and so let's go ahead and bring some terms together here. We have 5 and 3, which makes 8, and we have minus z and minus 4/3 z. So that would make, so I'll write this 3/3z minus 4/3z, right? Get the same thing on the denominator. So that's 8 minus 7/3 z. Okay? So now to write my points, or my answer, I'll write, so first you write the x, so that'll be 8 minus 7/3 z, and then you write the y, negative 3 plus 4/3 z, and then you write z. Okay, and then that's your answer. So if you were to plug in any value of z and you would get a point, that point would be an answer or a solution to this system of equations.